is Francesca Lucchini, and I'm the director of this project, and I'm also part of the tech transfer team at CENIA. The main subject of our project is how to do traffic or transit management with AI in the context of our country, Chile. This is part of a public contest from the Subsecretaría de Transporte, or in English, the Undersecretariat of Transportation. Before we begin, I want to present our team. Working on this project, we have a multidisciplinary team. We have professionals and investigators who are machine learning, computer vision, and transportation engineering experts. We need this because we need to work with different subjects, such as machine learning in the context of transportation. This presentation has 4 main sections. First, the context of this project. What is the problem we are facing and our proposed solution? Second, what does it mean for us to work with a human-centered smart cities approach? And third, some technical challenges we faced. And fourth, also some challenges, but related to decision making. Now to the first subject, the context of the project. First, I need to present our counterpart, the UOCT, or Traffic Control Operational Unit. What do they do? They manage and operate traffic control systems. They do continuous traffic monitoring and optimization, and they also do incident management. Why they decided to publish this contest? Because they needed help to facilitate people's mobility conditions. They want to focus both on pedestrians and vehicles. And also they want to add observability to previously unseen groups and issues. For example, they want to consider age and gender perspectives, and people will reduce mobility when they are making decisions. They also want to have information on accessibility, travel times, greenhouse gases emission, and other issues that were previously unobserved. Their current situation is that they are doing manual monitoring of the cameras and other sources of data. As you can see in the picture on the right, that's the control room. And they have over 300 cameras connected to CCTV and over 1,000 with private and municipal cameras. So those cameras are being manually monitored. Also, the interventions they do are based on only visual inspection of the available cameras, and they need metrics right now to measure the effect their interventions have in the city. Right now, they are only watching the cameras and based on their own criteria, deciding what to do, but they don't know the effect of those decisions. And they also need more information for long-term decision making and how to prioritize the information. How to prioritize what to intervene first. Considering this, our proposed solution was to assist monitoring with computer vision, AI techniques, and classic traffic simulation. We want to create solid traffic indicators or metrics that we can build from the several data sources that they work with. For example, they have cameras, they have flow sensors, they have access to Waze traffic travel times, and we want to measure, for example, flow of different vehicles and pedestrians. We want to measure speed, we want to detect crowds, estimate carbon emissions, and more. And of course, within those indicators, we want to detect anomalous behavior and to consider the privacy of the people in the city. We want to work with aggregated data that is anonymized. Here I have an example of our current solution working to detect different types of vehicles, including public transportation. And right now we are detecting, for example, for flow of vehicles, the direction, the trajectory, the object type, for example, if it's a private car, public transportation, a bus, or a truck. And we're also doing speed estimations. We're also working with pedestrian metrics, and we want to mainly have information on where people gather and are waiting, for example, to cross the street, and also the amount of flow and speed of an average speed of pedestrians. In most cities, there are many technological solutions that are used to improve the management and efficiency of the city. That includes traffic monitoring. For example, that's what the UOCT is doing with the cameras and traffic flow sensors. But we want to make human-centered smart cities. That is a very important part of this challenge. And here's what I mean by that. Why is it important to be a human-centered approach? It's because traffic affects everyday life of every person in the city. It affects their quality of life because it determines the amount of leisure time that we have and the accessibility we have to public services. But how can we help people? First, we need to improve observability of different groups, not only vehicles or motorized ways of transportation. We need to include pedestrians. We really want to include pedestrians and have a very high prioritization with public transport. And also another very important part that can help us to make it human-centered is the collaboration and communication with the UOCT, because they made it very clear to us that they really wanted to make this something for the people and not only to optimize traffic for vehicles. Now to the next subject of this presentation, the technical challenges we have faced. For example, the first challenge we face is that the cameras that are around the city have motion. They are moving cameras. They can zoom, they can tilt, they can pan. So if we really want to have useful information from speeds and traffic flow, we need to classify it as if it's moving from example from south to north or from east to west, meaning that we need to add to the camera's notion of the real world. We need to give it a real world orientation. Where is the north? The second challenge that we had is hardware limitations, because at the OCT, they are using the max capacity of their internet bandwidth to make the videos, to bring the videos from the cameras to their central operation room. And we can't propose a solution that uses a very big amount of internet bandwidth. We need to work with that. We need to adapt. And the final challenge that is very important is that the camera distribution is not equal. Cameras are mostly concentrated in the northwestern part of the city, which is the high income area, and the center of the city. So we have a lot of spots with not much visibility. That's when simulation comes in, and it's very important because we can feed simulation with information from surrounding cameras, and we can predict the indicators we want to make and measure them using the simulation. And on to the final part of this presentation, and the subject is decision-making challenges, and that is very related to the AI human rights toolkit. This project wanted to consider 3 types of groups to classify pedestrians. The first one is age. The second one is reduced mobility. For example, if someone is walking with a baby stroller or they have mobility assistive devices, because that means that there's an intervention that needs to be made for the infrastructure, or for example the traffic light timing to make the city less difficult to traverse. And the last one is gender. And they are all relevant for city planning, but we had some issues with some of them. For example, with gender and age. We don't have information or official registries from the city that have information on gender and age. For example, the public transportation card doesn't have any information on the person using it. So we only have the information of this ID card has been used here. And the main source of information we have are cameras. And that means that we only have visual features to base our discrimination. We can only use visual features to determine gender and age. And what does that mean? Since there is no data set built from Chilean population, we would be imposing gender and age stereotypes from other parts of the world for classification. Most data sets are Eurocentric. They are very Eurocentric and are based on people from other countries. And we would also be defining what, for example, means to be feminine, what means to be masculine, and what age you are supposed to be. And ethically, for us, that is not something we want to do. In the end, we decided to scrap gender and age classification for pedestrians, at least for now, until we have a more reliable data source that is not doing harm to the people. So I have not been working that long in AI. I've been working for a year and a half, but so far with this project, I have learned a lot of things. And the main thing I want to transmit to you is that we, as developers, as investigators, as people that work in AI, we have a lot of agency in how AI is used. In the example I just showed, it was a conversation that we have together with the OCT to scrap gender and age. That means that we can decide where to put our resources, where to put our focus. For example, another point in which we showed our, I can see that we have that agency, is that we can decide to focus on vehicles and pedestrians. We could have just focused on vehicles and said, well, pedestrians are too hard, let's just do cars. So there we have the option to make a decision. We also can decide what becomes measurable and how we can measure that, and has a huge impact on the result. So my conclusion is that it's crucial to have very different perspectives in your team. That's why I'm glad that our team is multidisciplinary, but it's also important to consider our counterpart. It's also important to consider what the people think. And that only happens if we do it as developers. Thank you very much.